In this video, we'll go through fine adjusting the two-stop method, where we won't use the side stop on our Pathfinder. Before adjusting, verify or calibrate your Pathfinder. Here is a simple list of some of the tools I will need. We'll start step 1 by creating a program in DXF in AlphaCam. Draw a 24-inch by 24-inch rectangle, and now would be a good time to save it as the needed DXF. Go to the Home tab and choose Output CAD. Have DXF set as a file type and click OK. All layers and 8 decimal places is fine. Then choose a location to save it. I'm going to call mine 24 by 24 test. And now we can move the rectangle so the bottom left corner is at X2, Y2. You can insert your table to verify the location. The bottom and left edge should be exactly 2 inches in. Then apply toolpaths as normal. Then delete the toolpaths on the top and right side. We'll only be running the cuts on the left and bottom edge. And finally, we can output the program by choosing Send G-code as normal. Save the drawing as prompted. I'm going to use the same name, 24 by 24 test, and this also becomes the program name. And next, we'll go run this program at the machine. Remove the stops, and then load the program at the control. Start the program, and then stop it when the blade is alongside where one of the physical stops would be. So here we can place the stop back into position so we can measure between the stop and the part side of the blade. You can use a tape measure or a caliper. I'm going to call this 2 3/8. Both X and Y should be at 2 inches. So we'll have to move the Y blade offset in the negative direction by 3/8 of an inch. Run the program again and stop when the blade is in front of the other stop. Then again, measure the distance between the part side of the blade and the physical stop. This one measures as it should at 2 inches. Now that we have our values, we'll go make our adjustments in the controller. Go to the Setup tab and then Advanced, then type in the password, which is Sunrise. You'll find the blade offset under the Work Table Offsets tab. Y is the only axis we'll need to adjust. We'll use the current Y value, 10.281, and we'll subtract the 3/8 to get 9.906, which we'll enter in. And we'll click OK to set it as the new offset value. Run the program again as we did before to verify that our adjustment was correct. Repeat this process until you are satisfied with the accuracy between the physical stops and this program's X2, Y2. Now that the blade position is accurate to the physical stops, we'll transfer the location of the left stop onto the Pathfinder's A-frame. Place the stops into position. The front 2 stops should be in the same position as the stops on the Pathfinder's A-frame. Place the foam firmly against all of the stops and use your straight edge and fine-tipped marker to accurately draw lines representing the edge of the stops. Then we can take this foam sheet and place it on the A-frame at the Pathfinder. Carefully align the marked lines to the stops on the A-frame itself. Pay the most attention to the left side of the left stop. Then draw a line on the left side of the foam with your fine point marker. This line will represent a boundary When taking photos of the slab, slabs must be placed on the A-frame to the right side of the line so they will be within the limits of our table at the machine. And next, we'll take a photo of our reference slab. But first we have to prepare it by drawing two straight lines parallel to the left and bottom edges. We found the 2-inch side of a carpenter's square worked well for this. We will be aligning our 24-inch square to this line, both in our photograph and cut marks later on. So make sure that these lines are straight, clear, and accurate. Next, move the slab to the A-frame of the Pathfinder. When setting it into position, ensure that the left side of the slab is perfectly aligned with the left side of the left stop. Double check and adjust as needed. Now we can take a photo of the slab. Take the picture as you would any other slab. You won't need to input any properties because we'll be deleting it. But remember the slab ID. Mine is 2985. Next, we can align the DXF to the lines we marked on the slab in Perfect Match. Open Perfect Match. If it's already open, shut it down and restart it fresh again. Now we can bring in the slab we just created and the DXF of the 24-inch square that we saved earlier. I'll choose File Open, Template, and then find my 24-inch DXF. Then I can choose File Open, Slab by ID. This allows me to type in the slab ID number that we saved. Now with both our square and slab in our Perfect Match, move the square onto the slab as you would in any other Perfect Match program. Take your time and zoom in and align it as well as you can. And when you feel you have the square lined up to the marks as good as you can, go to File and Export to export this layout. Again, save it where you can find it because we'll use this layout for the next step in making a program. Open AlphaCam and bring in the slab layout that we just created. Go to the Home tab and choose Input CAD. You can check all the boxes before clicking on OK. Browse to the location where you saved the file, select it, and then open. And then we can make a cut program on our 24-inch square by using Auto Toolpath like we normally do. And since we only need cuts on the left and bottom side to align with our marked lines, I'll delete the other two. I'm also going to change the depth to only score the material. I may have to run this program multiple times to align the blade to the marks. I'll use cooktop depth to achieve this. I think the depth of 1/4 inch would be fine. I'll select both cuts and finish, and then OK for each. I'm also going to delete the text so it doesn't show up on my printout sheet if I choose to use it. Then send the G-code as normal. The next step is to run the program on the slab on the table. Place the slab on the table and very carefully align the left edge of the slab to the left edge of the stop, similar to what you did on the Pathfinder. Also, verify that the bottom edge of the slab is tight up against the stops when it is in position. Then we can load and run the program. Load the program into the controller that we made to cut the left and bottom edge of our 24-inch square. And if the stops are removed and the slab is placed perfectly, press Cycle Start to run the program. Let this program run all the way through so we can check the cuts up against the marked lines. This cut that's traveling in the Y direction looks to be right on, where the blade is cutting just to the outside of the part. So its X position won't have to be changed. The cut traveling in the X direction, however, will have to be adjusted to the Y minus, or negative. We can measure these distances with a tape measure, or more accurately, a caliper. Measure between the edge of the slab and the edge of the part, and measure the other distance as well. The part edge of the cut line should be at the 2-inch line that we drew earlier, and instead we see it's at 2.766, and it needs to move in the Y negative direction. These are the values we'll need to use in the SlabSmith administrative database. Minimize or close SlabSmith, and then open the SlabSmith database administrative by double-clicking on the icon. I'll maximize a window for a better view. Then select Photo Station under General on the left side. Then open or expand the Slab Maker, and then do the same for the Pathfinder so that you can see your calibrations. Then choose the calibration we're working with. I was using the one called 3cm. This is where I can see the current origin and apply the shift distance. When we apply the shift distance in the Y origin, it will be in the opposite direction of the blade. We can visualize this a little easier in the slab layout. When we ran the program at the machine, the origin to blade relationship was correct in the X, but the blade needed to be shifted down in the Y. But here, we're adjusting the origin instead, and we're going to move the origin to the cut, which is positive. So a positive 0.766 is the value we'll enter into the shift distance for the Y. And when you press Apply Origin Shift, you'll see the values change in the current origin fields. That shift has been applied and saved. You can now close out of the SlabSmith database. Now, to check the adjustment at the machine, we'll need to make a new program. We'll have to start back at step number 4 to incorporate the origin shift that we just made. Reopen Perfect Match, import your slab and square, do the layout and export it. Then open AlphaCam and bring in your layout and program it, deleting any saw cuts that you do not need, and send the program to the machine. And when you go to run the program at the machine, if you left the slab in the same position, you will be able to see the adjustments made comparing the saw cut to the line we marked earlier. And we can call this task complete if the measurement comes out to within your expectations. And if not, you can repeat this process until you're satisfied. Thank you for choosing Park Industries.